Hello. Okay, so last week we talked about isosceles triangles a lot, right? And we talked about how if there's two equal sides, there have to be two equal angles. But the other thing that came up for us a lot was this idea that the three angles of a triangle have 180 degrees in them. That's actually a theorem in geometry on its own. It's called triangle sum theorem. And it very simply says what we've been saying, that if you've got a triangle, there's three angles in that triangle, they have to add up to 180, right? So in this picture here, we have angles A, B, and C. The measure of angle A plus the measure of angle B plus the measure of angle C has to add up to 180. That's literally just a geometry fact forever. Okay, so we have been doing that with just one triangle. Today what I want to do is show you how sometimes we can use that in more complicated diagrams to find lots of angle measures, and then tomorrow we're going to extend that into another theorem that you see here hiding below this blue block. Okay, so if you take a look at these problems here, you can see that this first one is just a pretty basic 180 degree, I'm going to get my calculator out, a pretty basic 180 degree triangle problem. So we know that if I take these three angles and add them up, 24 plus 37 plus this angle right here, I'll call it red blob, has to equal 180 degrees. Right? So I can take the 24 and the 34 and add those up. Oh, sorry, 24 and 37, and that's 61. So I know that 61 plus whatever that angle is has to equal 180 degrees. So all I have to do is figure this one out, is do 180 minus 61. So let's see, 180 minus 60 is 120, so 119 degrees. And we can always check ourselves by just adding up the three angles that I have. So what I'm saying now is that my three angles are 24, 37, and 119. If you can't add those and get exactly 180, you're in trouble. Okay, so let's see, 9 plus 7 is 16, plus 4 is 20, so carry the 2, 4, 5, 6, 7, 8. There we go. Check. Right? That's got to be 119 because they have to add up to 180. Okay. Now, in these two, they kind of added a little layer, didn't they? There's a triangle, and there's a third angle in this triangle that we do not know. That is for sure. They're not asking us for that angle. They're asking us for this angle outside. We call this angle right here an exterior angle. And you may be able to tell why we call it that. It's because you have this triangle and it's like there's a triangle and they made one of the sides like too long. Right? And when you do that, it creates another angle outside the triangle. And I can do that with any of the three sides, right? I can extend it that way. I can take a triangle and make that side too long, and I create an exterior angle out there. Okay? So in this problem, they're not asking us for the third angle of the triangle. They're asking us for an exterior angle. But we can find that angle still using the triangle sum theorem. Just have to jazz it up a little bit, right? So I know that 76, 52, and this angle right here, let's call it x, have to add up to 180, right? So 76 and 52, it's 128. So I don't know what this is, but I know it has to add up to 180 here. So if I do 180 minus 128, I get 52. Does that mean this is an isosceles triangle? So this angle right here is 52. But that's not the question they asked. They asked for this outside angle. So what I need you to notice is that this 52 degree angle right here and this angle we're looking for together make a straight line. And straight lines are the other place that we see 180 degrees. We know that triangles are 180 degrees, but before we knew that straight lines made up 180 degrees. So if this is 52, then this must be 180 minus 52. And we already know what that is. It's got to be 128, because we just did 180 minus 128 and got 52. So 180 minus 52 must be 128, and the measure of angle 1 is 128. Okay? Okay, so I'd like you to take a moment and try this one. All right, let's see. What do we have here? They put a little twist on this one, didn't they? I don't know what this angle is. This is the one I'm looking for. Okay. I need to know this angle too, though. I can't just take 79 and 104 and add them up, because 104 isn't in my triangle. It's an exterior, it's outside, but I can use it. I can use it to figure out this angle right here. This angle right here must be 180 minus 104. So that makes it 76. So this angle right here is 76. Well, now that I know these two, I can figure out this one, right? It's just kind of a two-step process now. So 76 plus 79 is 155. So to get this, all I have to do is do 180 minus 155. So what's that? 25. And there we go. Right. So we're still using our triangle sum theorem here, but now there's just this added layer that sometimes we also have to use the fact that a straight line is 180 degrees. Okay. And what we're going to see here are some diagrams that are a little more complicated than just a triangle, or even a little more complicated than just a triangle with one side extended with an exterior angle. The goal here that we're going to have is to just start one piece at a time, piece them together, figure out the angles. Okay, so case in point, look at these two. Now I want you to think about all the angle relationships that we know. Let's write them over here. We know that a triangle is 180 degrees. We know that a straight line is 180 degrees. We know that right angles, like complementary angles, right? If you have a right angle and it's broken into 2 or 3, those have to add up to 90. And remember our old friend, vertical angles. Don't ever forget about those. Those are congruent. Okay, so we know all these things, and what we have to do in these diagrams is mash it all together to figure everything out. Okay, and it's really important to note that you might take a different path than somebody else. You might see a relationship and somebody else sees something different. It's perfectly fine. What you're looking for is a relationship you know that can help you get something. So for example, somebody might look at this and say, you know what I see? Look here on the left-hand side. I see a triangle, and it has 100, and I know this triangle has to have 180 degrees in it. Right? This purple triangle right here has to have 180 degrees in it. So I can use that to figure out angle 1. I can say, okay, if I want angle 1, 66 and 84 is 150. So 150, so 180 minus 150, it gives me 30, right? So I know angle 1 now, it's 30. Somebody else might say, you know what I see? When I look at this, I see that these two together make a straight line. So I'm going to get angle 3 first. So they go, okay, well, 180 minus 84, that leaves me with 96. Angle 3 must be 96. Those are both perfectly valid starting places, right? It doesn't matter where you start. You've got all these different angle relationships that you can use. You may start in a different place as somebody else, and that is perfectly fine. Okay, here's what I want to do here, though. I want to clean up this diagram a little bit. So right now we know that this one is 30, and we now know that this is 96. Okay. The last one up there that we need to find is that angle 2. Oh, if having a little troubles with my pen today. I have troubles with my pen every day. Am I kidding? Okay. So what I need you to see here is, in order to get this 2, and there's a couple ways you could get at it, right? For me, I look at this and I say, okay, well, I have this triangle here on the left, right? And I know it has to add to 180. So all I have to do is figure out angle 2 is go 96 and 43, 139. So let me figure out angle 2. That would be 180 minus 139, right? So that's 41. Ta-da! But somebody else might come along and say, you know what I see? I see this really big, one big triangle around the outside. And if they see that, then they say, okay, so it has this angle here that's 66, and this angle here that's 43. So 66 and 43 is 109. And then they say, okay, so this whole big angle up top here has to be 71. Okay. Well, this angle up top is made of 2 angles, a 30-degree angle and the one I want. So if this whole thing is 71, then this is 71 minus 30, which is 41. So notice, they got the same answer. Did it a little differently, but they got the same answer. Okay. Take a look at number 6 and give it a shot. See what you can flush out of number 6. Okay. So the first thing I notice when I look at this thing is I see 2 triangles that are stuck together, right? As soon as I see 2 triangles stuck together at a point like this, I'm like, boom, boom, vertical angles, they're jumping out, they're screaming at me. I know angle 2, it's 61, right? Because vertical angles always jump out at me. I told you they're the only thing I remember from high school geometry. Okay. So now I know angle 2. Somebody else might say, you know what, the first thing that jumps out at me is this triangle on the top. I have the 61 and the 68. I'm only missing this angle 1. So that should be pretty easy to find, right? 61 and 68, 129. So I can figure out angle 1 just by doing 180 minus 129. So 51. So now I know angle 1. It's 51. Doo-doo-doo. That only leaves me with angle 3, and angle 3 is sitting down here in this corner. Right down here, if I can find it. What the heck is going on today? There we go. There's angle 3 right there. Okay. So again, I only have so many relationships. I have that 180 adds up to, or that a triangle or a straight line adds up to 180. I got this 90-degree thing, and I got this congruency thing. Vertical angles. I used vertical angles. Look down this triangle. It may not appear at a glance as though you've been given enough information, but remember what this little symbol means. 90 degrees. Okay, so I do have 2 of the 3 angles, just like I did up here. So all I have to do is use my triangle sum theorem, right? So 90 and 61 is 151. So 180 minus 151 is 29, and I got my angle 3. Okay, so listen, some of these diagrams are more complicated than others. Some of them have 3 or 4 triangles stuck together. Those ideas that you see on your screen there, please make sure you write those down so you can reference them while you're working on some of these problems. You're going to use those same rules every time. Okay, so I would like you to head over to Desmos and try some of these, and I will be there to spy on you. Have a wonderful day. See you soon.